We are asked to sum a series at the start of this question, so let's write it down. I think it's worth just writing down a few terms in it as well. So it's going to be x to the 0 plus x to the minus 1 plus x to the minus 2 all the way up to x to the minus n. Now this is the first indication that you need to be a little bit careful because you can see we've got n terms here. So in total, we've actually got n plus 1 terms. And this is a geometric series. A is equal to 1, and the common ratio is going to be 1 over x. Now, in the final answer, they've left it in terms of indices, so I'm going to write it as x to the minus 1. So the sum of n, except I don't want the sum of n, I want the sum of n plus 1, so I'm going to write that formula down, is going to be a 1 minus r. Now, it's normally r to the n, so it's going to be n plus 1 here, and then 1 minus r. That's the only difference when I'm summing n plus 1 terms. A is equal to 1, so I could just ignore that. And I'm going to get 1 minus x to the minus 1, so it's going to be x to the minus n plus 1 over 1 minus x to the minus 1. Just going to grab down the actual answer because that's where we're headed. At the moment, you can see that I've got an x to the minus 1 in the denominator, and there is not 1 in the answer, so the next step is going to be to multiply through by x. That will sort out the denominator completely. So times the top by x and the bottom by x. But when I times the top by x, remember this is x to the minus n minus 1. So when I times by x, it's just going to become minus n. And we're nearly there. We can just separate it into two fractions. B, we're asked to hence. That means use part A to find an expression in terms of x and n for this summation here, for x not equal to 0 or 1, and to simplify our answer. Okay, so that's sort of there. That's what we're trying to get to. And remember, we have this result here. Now, what jumps out to me is the fact that they've kind of brought an R down. And one way of achieving that would be to differentiate the summation. And what you can do is because essentially we are, you could sum the whole thing and then differentiate, or equivalently, you could differentiate each term and then sum it. I'm not going to get into lots of proof on that, but just like you can bring out a constant, you can do this as well. It's essentially, I'm just sort of saying that if you do this, then it's the same as doing d by dx of x squared. Like that's what you normally do without even thinking about it. So me bringing this in isn't like, you know, ridiculous. It's just using concepts we already use. It's just it looks a bit more strange. And so that will equal minus r x to the minus r minus 1, or I can put it in a bracket like this. And I can also then bring the minus out. That's something you're allowed to do with summations. It's a constant. You just sort of bring it out, do the summation, and then you would times through by the minus at the end rather than each term separately. And then also, so this is good because now like we have the thing we need that we want to find. Okay, we've got a minus in there, but that can be easily dealt with. Now we've proven, remember, that this thing is equal to this. So I can just differentiate that as well. This is going to be two lots of applying the quotient rule. So in each case, that would be u, that would be v. And remember, it's u prime v minus u v prime over v squared. So it's going to be 1 times x minus 1 minus x times 1 all over x minus 1 squared. And then over here, minus nx to the minus n plus 1 times v. And then minus u times v prime, which is just 1. I can just about fit it in. And this is a thing that we're going to have to simplify. So I'm going to get x minus 1 minus x. And then over here, I'm going to get plus, because there's a double negative, n x minus 1 x to the minus n plus 1. And there's a double negative over here, so it's going to be plus x to the minus n. This is going to cancel with this. Okay, next step. Going to continue to multiply some things out. So I think I'll write it. What should I do first? Okay, I'm just going to write it the same again, but expand this bracket out. So I'm going to get nx times x to the minus n plus 1 minus n x to the minus n plus 1 plus x to the minus n. This thing here, this x is going to cancel with this 1. And so I have an x to the minus, I've got n lots of x to the minus n, and I've got 1 lot of x to the minus n. That will actually be n plus 1 lots of x to the minus n. So I'll write that one. And then I'm going to be minusing n x to the minus n plus 1. And I put the minus 1 over here now. We can't really simplify this any further. It's pretty good. Now, just remember, this isn't actually the final answer, because that is what this negative thing is. So we just got to finally basically swap all the minuses around on the top. So we found that it was, oh, sorry, it was an r plus 1. So this is going to therefore equal 1. I'm just going to put the 1 first, plus n x to the minus n plus 1 minus, oh man, I can't fit it in. Come on. technically I should probably just say that x x can't equal 0 or 1. You can clearly see why it can't equal 1 because you would yeah, you couldn't have been applying a lot of what we've been applying from the start. And if x was 0, yeah, the whole process falls apart because you'd just be adding lots of zeros. Whereas if you in the summation, you would actually not get 0. So x not equal to 0, equal to 1. Finally, we're asked to find this summation here, and you can bet that it's going to use the previous result. In fact, you can see it, but let me make it really clear. So we can actually separate it into two summations. It's going to be 3 times 2 to the minus r, and then I can also sum 5r times 2 to the minus r. I've just split it up and put it into two summations. I can take that 3 out. Now this here is looking very much like what we did right at the start when we had to sum x to minus r. We've got to be a bit careful with the other one because we've got an r there, but actually we needed a minus r minus 1 essentially. So I'm just going to make it really clear. So this thing here is actually going to equal 2 to the minus r minus 1 times 2. I can lower 1 from the power if I times by 2 to compensate. And therefore, I'm going to get 5 times 2. I'm going to get 10, which I can bring out. That's probably the most easy place to slip up on this question, aside from the very, very start where you had to realize that there were n plus 1 terms. So it's going to be r times 2 to the minus r plus 1. So now they're both in the right sort of form. We can use this formula here for the first one. Sorry, I didn't copy. Let me try that again. Okay, take 2. We can use this formula again here. I'm going to times by 3 at the end. I'm just going to focus on this bit. So it's exactly the same, but with x replaced by 2. So it's 2 minus 2 to the minus n. And then I'm just going to focus on this one as well. And for that, I can use this formula. Okay, so it's exactly the same, but with x replaced by 2. It's just going to disappear. Now, I think I've got enough to bring it all together. So therefore, the sum r equals 0 to n, 3 plus 5r over 2 to the r will equal 3 lots of 2 minus 2 to the minus n plus 10 lots there's no way I'm going to be able to fit that in. 10 lots of 1 plus 2 to the minus n plus 1 lots of n minus 2 to the minus n lots of n plus 1. And we were asked to leave it in a very specific form. And it doesn't look like we're anywhere near that at the moment, but that's what we've got to get to now. So it's going to equal 6 minus 3 over 2 to the n. Sorted this. Plus 10 plus 10 over 2 to the n plus 1. I'm trying to do this really carefully. Oh, and I missed the n out, so 10n. 10 times n, and then it's all over 2 to the n plus 1. And then minus 10 to the n plus 1 all over 2 to the n. Okay, that's a good start. So I can bring the 6 and the 10 to give me 16. And I can nearly bring the rest together. I've got 3 over 2 to the n. Right, this thing here is going to be 2 to the n times 2. So it's going to become 5n over 2 to the n. And then minus 10n over 2 to the n minus 10 over 2 to the n. I'm just going to separate it all for the moment. Right, minus, then it's going to be 3 minus 5n plus 10n plus 10. (13) plus 5n. Okay, I took my time there. I didn't want to make a mistake. And I've got there. So that's our answer. It's a pretty neat answer for what looks like a really complicated summation.